Hey, welcome back. So we're going to look at the temperature dependence of solubility, and we're going to start off looking at a series of solids in liquids. And so we're actually going to kind of focus our attention on water here, just because water is the liquid that we most generally dissolve things in the general chemistry lab. And well, there are some exceptions, but you can see, something like calcium chloride, this curve here, as you increase the temperature, so the temperature's on this axis here and the solubility is on the other axis, then it tends to become more and more soluble with temperature. And here's potassium nitrate, so you can see it starts out, relatively insoluble, and as you heat it up right, its solubility can increase by a factor of 10 over this curve here. Something like salt is fairly flat here, so it gets slightly more soluble with temperature, but not excessively so. Almost every curve you notice goes in this upwards direction, which means that as you increase the temperature, it gets more soluble. But there's a couple of exceptions here, and actually there's just one exception on this graph here, and that is this cerium sulfate. So this is cerium 3 sulfate, I believe, and you can see it actually gets slightly less soluble with temperature. So I just want to point that out because in general, the solubility of solids in liquids increases with temperature. And again, that's a very nice rough and ready rule of thumb. It's almost always correct. So almost always you will get more stuff to dissolve in hot solvent than cold solvent. That's why you wash your hands in hot water. At least I hope you wash your hands in hot water, because hot water is just much better at dissolving solutes than cold water. If we contrast what we saw with solids in liquids with gases in liquids, we see that the solubility tends to decrease with temperature. So this line here, I guess, is nitric oxide. This is oxygen. This is nitrogen here. We can see that as we increase the temperature, we typically decrease the solubility. And this is given in milligrams of gas per 100 grams of water. And we make use of that. So for instance, if you want to make ice cubes that are perfectly clear, you know that the trick is to actually boil the water before you freeze it. And by boiling the water, you actually help to remove and undissolve, if you like, all those pesky atmospheric gases. And then when it cools down, particularly if you cool it down very quickly, the gas doesn't have a chance to redissolve in there and it crystallizes out in a much clearer fashion. So if you want to make really nice, beautiful ice cubes, you need to get rid of the gases. So if you boil the water, it removes all that extra gas from there. So that's pretty awesome, right? Now we can make use of these ideas. So for instance, where are you most likely to find fish? Probably in regions where there's a lot of oxygen dissolved in the water. And because oxygen increases in solubility for colder water, you'll typically find that the colder areas of the earth have more oxygen dissolved in the ocean. And this is where the fish start to migrate to. So for instance, the changing weather patterns on the earth, if they create cold spots in the oceans, fish are going to migrate into there just simply because there's a lot more oxygen dissolved in the water there. And this also explains why pop is probably better drunk cold than warm, because when it's cold, the carbon dioxide stays dissolved in the solution much more effectively. But when it's warm, you can see that the bubbles fizz out and it just goes flatter much quicker. So you're better off keeping your pop in the refrigerator, although you probably knew that anyway, I'm guessing.